record. Should be recording. All right, how is everyone?
Doing good. How are you?
Doing okay.
Pretty well.
All right, so we made it to week 9. So today I want to talk about the ODPs from last week, talk about this week's ODPs, make a few comments on PA4, answer questions about PA5. I want to go through some examples on the command line of doing things like displaying dialog boxes, capturing output, going through an appointment file, looking for records with particular date characteristics, things like that. That will hopefully help with PA5. And then we'll probably have time left today to wrap up regular expressions, look at some of the exercises that I pointed you to last week and work through some solutions to those. And then probably on Thursday, we'll talk about processes and look at process creation, working with processes from Bash and from C and so on. And then Tuesday, we'll do kind of a wrap up, talk about what to expect on the exam, go over a list of topics, things that you should know about Bash and Bash programming and so on. And then there's no class next Thursday because of Thanksgiving. And then the final week we'll be doing PA5 presentations. So that's sort of my plan from this point forward. Yes, there will be office hours on Tuesday. But I will not have them on Thursday. And I will not have them on that Friday after Thanksgiving either, but I'll have them Tuesday. Yeah, you're welcome. All right, so questions you want to talk about up front?
Yeah, so for the sed command, but in VI, like I forgot the formatting to get it to actually run in VI. I know,
So
like
in VI,
all that, but yeah.
So you can say : substitute something with something else, and it will perform that substitution on the line that you're currently at.
Okay, so it's just directly after the colon then.
Mm-hmm.
Okay, yeah, that's
and then
what
if you want to do it on a range of lines, you can say, between lines 1 and 10, substitute old with new.
Yeah.
And if you want to do it on the entire file for your last line, you can use a $. And that's synonymous with whatever the line number is of the last line in the file.
All right, thank you.
Yeah, you're welcome. And on Canvas, there's this regular expression summary, which goes through a lot of goes through everything that we've done basically, plus a little more. So anchors, caret and $sign for beginning and end of line, period matches any character, asterisk matches any number of occurrences of the previous pattern. Putting things inside escaped parentheses makes them into a pattern that will get saved in a register. And then you can grab the value of a register with a backslash followed by the number, the register number, in the replacement part of the substitute command. A general character matches any character unless it's special, like a period or a star. You can put a backslash in front. To escape it and say, I actually want a $sign, you can say \$, for example. Things in brackets match any of these characters. Things in brackets with a caret in the beginning matches anything except those characters. And then in VI or sed, you can say s/old/new. You can put a G at the end to say do it multiple times on a line. And you can list a pair of line numbers, like line 1, comma, line 2, substitute old, new, and you can do a $sign to mean the last line. You can also do arithmetic, so you could say dot, colon, dot -5, which would substitute, 5 lines before where you are up to the current line. So that's a summary that's available. Doesn't percent mean the whole line? I'm not sure what context that is. How do we save an associative array into a file? If you want to save anything into a file, you can echo it and output to the file. So if you do something like command greater than file, the command will be executed, and whatever gets sent to standard out instead of appearing on your screen goes into this file. And if you do command greater file, that doesn't append. So this truncates the file, zeroes it out, and then just replaces the contents with the output of the command. This will leave the file intact, but will add to the end of it. Tips on pointers or hints on how to delete an appointment. Yeah, let's dig into this. So let's make our appointment calendar. So all right, so here's my bogus appointment calendar. And you can organize this file however you choose. I'm picking a very simple format. Year, month, day is the date of the appointment, and then a pipe, and then everything else on this line is a description of the appointment. So let's say that I want to look for appointments on the 15th. I could say grep for beginning of the line 2022-1115. And let me be really precise about this. Let's search for the beginning of the line, followed by that date, followed by a pipe. This is absolutely going to give me every record, and only every record that begins with this date followed by a pipe. In other words, appointments on that date. Now let's suppose I want to remove every appointment with that date. If I change my search pattern by saying grep-v, then it shows me all the records that don't match this, which is basically all the records on dates other than the 15th. So that's the first view of deleting an appointment, but it's pretty heavy-handed because I probably don't want to delete everything from the 15th. Maybe I want to delete, one particular appointment. Maybe I just don't want to do something for the end of the week. So you need a way to let the person choose, which appointment they want to delete. And specifying it by date is probably not sufficient. And you can specify it with the description of the appointment, but that can get a little tricky, right? Because they would have to type it in exactly. And if they type in, part of the appointment and you match that, well, maybe it says, do something for 2022-1114, and that's the description, and my grep command might pick up this and think that that was something that the user wanted to delete. So this is your file. You get to do whatever you want with this. And one thing you can consider doing is putting some sort of ID in the beginning of each record. So we could have, something like this. And now when you are working with the file, right, you could, say, what do you want to do? I want to delete a record. Okay, what date do you want to delete? I want to delete from the 15th. So now you show the person every record for the 15th in, a checkbox or a radio box or something like that. And you say, which appointment do you want to delete? And maybe they click this one. Well, you can build data structures inside that says, hey, when they delete this, that's record 3. If they select this, that's record 5. And so the user is saying, hey, I want to delete this appointment for office hours on the 15th, or I want to delete my remote class for the 15th. But in your script, you figure out from that the record number of what they're trying to delete. And you use that when you say, okay, let's delete record 3. And so you could do something like grep-v _3 pipe appointment, and that'll show you all the records except for record 3. So how do you actually delete this from the file? Copy the appointment file to a temporary file. Do this grep on the temporary file and save the output to the appointment file. And now your appointment file, we've deleted record 3. So those are some of the things that you can do to process the file. If somebody wants to add a new appointment, run dialog options, right, to get their date. And the name of an appointment. And then, if you're doing a record number business, you've got to somehow figure out what the record number should be for this record and append that. And there's different ways you could do that. So maybe you do that and you figure out that your new record number is 6. And so now here's the record that I want to append to my file. It's the record number followed by a pipe, followed by this line that I constructed with a date and a description. And if I do greater than appointment, now my appointment includes this new record. Yeah, you're welcome. So you can do a lot of stuff with grep and grep-v and some stuff with sed and so on, but you still have a lot more options if you play around with this this loop. Which says while read record do body of a while loop and then done less than file name. So if we do something like this, I'm going to say while read record do. And initially, I'm just going to print out what the record is that we read, just so we can see that this is actually working. I'm going to say done less than appointment. So this should read from our appointment calendar. And so it lets me look at each record one line at a time. And so what can I do with this? I could I could say, for example, let's see if this record matches the date that I'm looking for. So maybe I've got, date equals 2022-1115. To look for records with this date. This would, normally not be hardwired in my bash script. This would be a date that the person picked from a calendar and dialogue or something like that. So let's do the following. Let's echo our record and pipe that into grep caret, or let's look for a pipe followed by the date followed by a pipe. All right, so I'm going to search for this date surrounded by pipes inside each record that I read from my file. And if I do that, right, it shows me one line, but I don't really want to do that. What I want to do is know when I've read a line from the file that has this date in it. So let's do the following. Let's do this echo, but let's send the output to dev null. We don't want to actually see the output. But what I want to do is know, did it find that date in that record? So I can search for $?? Right. So what's happening here? I am echoing a record that we read from the file. This will be one line at a time. And I'm taking that line and I'm running it through grep, which searches for something. What am I searching for? I'm searching for the date surrounded by pipes. I'm putting the output of grep into dev null, so I don't actually see those matching records, but I'm checking the return value from grep. That's what $? will do. It will tell me, did grep succeed? If it returns a 0, that means success, which means it succeeded. It found this pattern in this file. In this case, the file was, just this one line containing the record. So if that matches, then it'll say, matching record, and it'll show me what that record was. So I can do that. And now I have a way to look at my file one line at a time and make decisions about it. And for example, look at this record and maybe display it to the user, ask them if they want to delete it or whatever. So don't underestimate the power of this. All right, this is a good way to process your file in a more controlled way than just trying to do the whole file with a single grep or a single sed command. And let me mention up front, if you start down the rabbit hole of looking online for ideas on how to do some of this stuff, you will find some very slick approaches to doing all these things that are not going to help you in the least on the final exam, right? On the final exam, you want to understand things like looping with a while read less than a file name. You want to understand how to echo something and pipe that into a command. You want to understand how to use $? Right? These are the building blocks that we're trying to make sure you understand as part of this course. And finding some slick one line way to do something online might give you a slick looking program, but the goal is really to learn these fundamental building blocks. So you're much better off taking what what we've gone over, asking questions about those and figuring out how to turn those into a solution that you're looking for.
So on your while read rec, and I think I asked this before, but I just don't remember the answer. Is rec just a random name that you're picking, or is that like a file you have made?
That's just a name.
It's just a name. Okay.
Yeah.
Okay. So it doesn't really matter. Like the while read doesn't have to be the name of like our appointment text file or anything like
Nope,
that.
it's just a variable. So this will work perfectly well too.
Okay. Cool. Thank you.
Mm-hmm. So yeah, edit boxes don't actually change the file. Right, so here's an edit box. Let me change my setup. All right, so there's an edit box and I can put some stuff in here. And then when I say okay, right, all of that just kind of like gets splashed out on my screen. And my original file is unchanged. So we can capture this in our usual way. We can say something like, new equals back quote, all of this stuff, dash output FD1. And now I can come in here. And put some extra stuff. And then if I say okay, it doesn't appear to do anything. My original file is still as it was, but I have this variable $new, which contains my modified file. And so if I echo quote $new, and let's put that into main2. Well, if I look at main2, now that's my modified file. It's got my extra stuff in the beginning that I typed in. So the trick is, right, run your dialog command in back quotes with the output FD1. That captures the modified file into this variable called new. And then if you just echo that inside double quotes and put the output into a file, that'll create a new file, which is the modified version of the old. I'll point out, though, that you probably don't want people to edit your appointment file directly, right? If they want to change an appointment, don't just open up the entire appointment file and say, go ahead and make your changes. Because now you're requiring the user to be very careful and deliberate in what they do. And if they mess up the formatting, it might crash your program. They could change, other appointments inadvertently and so on and so forth. So you probably want to just get, the modified appointment from them and then edit the file yourself in the script.
So I have a little bit of a specific question.
Mm-hmm.
So in the code that you had written with the while read rec,
Mm-hmm.
you're basically hard setting the date and you're using the last saved argument or whatever you want to call that, and saying 0 means it matched, 1 would mean it didn't match.
Mm-hmm.
How would you go about like looking at dates that are like greater than the date you have hard set? So like if it's reading an appointment that's for like tomorrow instead of today.
Mm-hmm. So the way I wrote my dates in this sample file we're like this: year, month, day. And the nice thing about storing dates like this is that chronological order and numeric order end up being the same. So if I have 2022 1115 and 2022 1116, well, this date comes after that. This number also comes after that. If I switch to December 1st, this number still comes after that, which means this date comes after it. If I switch to a new year, even January 1st, 2023, this number is bigger than all of these, so this date comes after all of those dates. And by doing year, month, day in that order, you can treat these as just plain integers and see which records come before or after others. So in this case, let's make our date the 14th. And instead of doing this echo, let's pick off that first date. So let's play with this inside the command line. So let's pretend that we just read a line from the file and we stored it in a variable called X. And what we'd like to do is know what the date is in this record. So you may not have record numbers in the front, or you might have timestamps, or you might have a username or something like that. Don't worry about the particular format of this, but whatever format it is that you're using, suppose the date is, in one of these fields and you want to get the date from this line. So this is where we can use awk. And awk, can do a lot of things, but the simplest version of awk is just the following: awk, single quote, curly bracket, print, $2, curly single quote. And this is the main version of awk that I want you to take away from this course. So let's try this. Awk, print, $2. This is a test, and it prints the word is. A, B, C, D, E, and it prints out BBB. So 23, 34, 45 prints out 23. So what is this command doing to each line of input? It's breaking it into fields separated by spaces. And this instruction is printing the second field. So the word is, the word BBB, the number 23. Now I can also change awk's behavior, and I can say, let's do some other separator, for example, -F, comma. And if I do awk -F, comma, right? It doesn't print anything because it's no longer using spaces to separate fields. But if I say this comma is a test, it sees is as the second thing on that line. So instead of separating words by spaces, I can separate them by something else like commas. Well, if I'm using pipes to separate the fields in my array, in my appointment calendar, I could say -F pipe and say, hey, this is the separator from one field to another. But remember, pipes have special meaning in bash, so I need to actually say -F \pipe. And the backslash says, I'm not trying to pipe one command into another. I just want the character pipe. And so now if we say something like awk -F \pipe, print $2, and I type in a line like this, this will print out that second field, this. And so if I were to feed awk a line from my appointment file like this, it prints out the date. All right, so I've got this variable X, right? I can say echo quote $X, and I can put that into awk -f \pipe, print $2. And now I can take this string that I read from my appointment file and print out the date. And if I say something like new date equals back quote, all of that stuff, I can capture that date from that line and save it in a variable. So now I can go into my main program and I can say, grab the date from this line of input. And so my line is in blah, blah. And this is going to echo the line I read from the file, put it into awk, separate the fields by pipes, print out the second field. That's going to be the new date. And now I can say something like if $new date is greater than or equal to whatever date I'm looking for, then let's print out the record. So my date in my file is the 14th. My appointment contains, one record on the 13th and a bunch of appointments that come after that. So if I run this and I fix my syntax errors, right, it shows me my records where the date comes after the 13th.
That's kind of cool. Yeah, I guess I know you've mentioned awk before, but it didn't even like cross my mind that was like a thing.
And awk is super useful in this way, and really the main thing is just print $2, or you can print
So is that $ number like scalable? Like since if you put 3 and you put $3, it would just give you the third. Yeah, cool, awesome.
And you can put things in between inside double quotes, or you can put commas between these, and I think it spaces them out. And this is a really good example of something you can work with on the command line. All right, if I do that, it's putting a space between fields 2 and 1. If I do this, it's not putting a space. If I do this, it's still not putting a space. If I do this, it's inserting the word and followed by a space between $2 and $1. And so you can experiment with these commands, right? I mean, you can go to Google and you can read about them. You can go to Stack Overflow and you can buy an entire book from O'Reilly Press that talks about the awk command, but you don't need to do those things. You can go to the manual page, but you don't necessarily need to even do that. You can just mess around with it, right? And see what it can do. You're not going to hurt anything. And just mess with it, What if I asked to print a field that doesn't exist? Well, no harm is done. It just prints a blank line. Can I print the same field more than once? Yes, absolutely. What does awk stand for? I don't know. I think I read this once, but I don't remember. but Brian Kernighan was involved. Kernighan's one of the inventors of the C language. So it's pretty old.
I Googled it and it looks like it's like the initials of all of the last names of the people that made it. Iho, Weinberger, and Kernighan.
Okay, cool. Awesome. So they could have done Caw.
That's how I made my text file. I did all of our Team Quamp, and that's the initials
Nice.
of all of them. Like,
Excellent. Let's see. How can I make the separator a character that can't be typed? So you can do some things with yeah, that works. So you can type a Control V to escape a character. This is an interesting thing to do. For example, if I want to echo escape bracket C, I can try to hit escape bracket C. But it doesn't really work the way I want. If I say echo and I hit a Control V for verbose, followed by an escape, and then bracket C, I can actually echo, you know, an unprintable character. So, so that's one answer. I don't know if you can do ASCII codes. Let's see, how's my octal? Backslash X1F, did that work? Yeah, I'm not sure I know an easy way to do that.
So I know you can echo special characters. I just don't know how to put it into awk.
Try putting a Control V in front of it. Like as you're typing it, type a Control V followed by something else. And Control V lets me, for example, I can say echo Control V, and if I hit the Enter key, instead of ending my echo command, it prints out $M, which is, you know, the representation for ASCII code 13, which is what an Enter key generates. And then it just prints an empty line. So sometimes that can get you pretty far. But the more usual approach would be to use some printable but uncommon character in your file to separate things. So for example, you know, using pipes, most people won't put a pipe in the description of an appointment. And if they do, right before you save the appointment in your file, you can do something like search that line for pipes, and if you find them, change them to underscores or something like that. So if the person types, you know, go to the pipe store. Well, if I try to store this in my appointment file, it's going to look like, you know, this is the description and this is, you know, maybe a timestamp that I put after these and so on. So an easy sort of hack to get around that would be to do a sed, substitute pipe with underscore globally, which will replace pipes with underscores. And so if I echo $appointment, and I pipe that into sed, I'll get the original appointment, but my pipes have been removed. And then I can do something like, you know, clean appointment equals back quote, all of that. And then if I echo clean appointment, right? So I can pre-process their strings to make sure that they don't have field separators in them. And then I can just go ahead and add that to, you know, the end of the record that I'm creating. So the recurring theme in all of this is, you know, it's a lot of do-it-yourself techniques. You have a set of things in your toolbox. You have awk, you have sed, you have grep, you have regular expressions, you have echoes, you have back quotes, and figuring out how to use those to do what you want to do. And you should have enough tools in your toolbox at this point to do most of what you need. And we'll go through some other ones in a little bit. So let's talk about dates. So we have a date command, which shows us the current date. And it's got, you know, a long-winded way of displaying the date. Well, if you look at the manual page for date, you can specify a format that it'll use to display the current date and time. And your format options are, you know, any of these things. If I want the full month name, I can say %B. If I want the day of the month, I can do %d. So if I say date plus %D %B, it says 15 November. So a useful format is %uppercase Y, %lowercase m, %lowercase d. That gives me year, 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 month, month, day, day. Right, which is this particular format that we said puts things in numeric order that corresponds to temporal order, to things being sorted in time. And so if I want to know the current date, I could say something like, you know, today equals back quote date plus %Y %M %D. And now I've got a variable with today's date. And if I do that in the beginning of this script, right, then this would show me all the records that have a date on or after today. All right, what about capturing a date from the user? So let's do dialogue, calendar. Like this. So the user can pick a date and say, okay. And so now the date that they selected is inside this variable $date. Oh, cool. Okay, that's a good hack. I like that. All right, so we can run a dialogue command like this. We can do the output FD1, put the whole thing in back quotes, capture the date that the user selects. The date they selected is day/month/year. So let's make another bash script called getDate. All right, so we're gonna just kind of creep up on this. We're gonna write a little bit of code and see if it works, and then we're gonna keep adding to it. So let's just try this basic get date. And so I'll pick, November 2nd, and it tells me date equals 02/11/2022. All right, let's break this into a year and a month and a day. So if we think of this as a set of records separated by slashes, it looks like the day is the first field, the month is the second field, and the year is the third field. So we can do the following. So I'm going to echo that date string and pipe that into awk. I'm going to tell awk, hey, let's look for the first field where our fields are separated by slashes. So separated by slashes, first field would be this 02. And I'm going to set day equal to the result of that. And then I'm going to set month equal to the same thing, but I'm going to print out the second field. That's the 1/1. And then I'm going to set year the same way, but I'm going to print out the third field. And then I'm going to set year, month, day equal to $year followed by $month followed by $day. And then I'm going to print out that year, month, and day. All right, so let's go ahead. Let's do November 2nd. Let's pick that. And I needed a $sign in the front of these dates. All right, let's pick November 2nd. And so the original date was, this date that came back from calendar. The modified date is our nice, 8-digit integer with the year, the month, and the day. Right? And there's no magic here, right? There's nothing peculiar going on here. This is just get your hands in there and start doing stuff, right? This is run the dialog command. This is prepare to capture the output. The back quotes say capture the output. And this says store it into this variable date. And we've talked about awk, and this separates fields with a slash. And this says, print the first field, second field, third field, save those in variables, concatenate them by just listing them side by side inside double quotes and store that in another variable. And bingo, now we can run our calendar dialog, but we can get the date the user selects in this nice format that we can use to go ahead and, put in the beginning of our appointment file or whatever we want to do with it. So this is the essence of PA5, right? Not this code, but this process of taking these pieces and putting them together. Is that making some sense? Cool. All right. What else should we talk about with PA5? What other issues are people running into? How do you recommend displaying dates? Displaying where or why? Like if you're showing appointment information, you can just, print out a record in a message box or an info box with, a date in whatever format you like. So year/month/day or whatever, up to you. And I don't think it has to be anything fancier than that. So if a user wants to view appointments, you've got some options. You could take all the matching appointments and put them into a file, and then use one dialog to display the entire file. And don't make it editable, but let them see the contents of the file like that. Or you could display them in a checkbox format, and checking the box might not mean anything, but that gives you a scrollable window. Or you could display them one at a time, or you could display them 5 at a time, and do that in a message box, and have instead of a yes button, change that to say show more. And so you could display 5 appointments, and if they hit the show more button, go ahead and show the next 5 appointments, and so on. You can really kind of bling it out as much as you want, and sort of explore that design space. Simplest way, just put the appointments in the file, display the whole file, let them scroll through it. But you can be more nuanced than that. And if you display them like in a checkbox, a checklist, right, you can add extra buttons to the dialogues. And so you could have an option for okay, or delete an appointment or edit an appointment. And they could click a radio button maybe, and then say delete appointment, and you could delete it like that. Or they could click a radio button and say edit appointment, and then you could show them the description of the appointment in a input box, set that up as the initial input, and let them make changes to it. Yeah. So let's see. So here's my little cheat sheet on associative arrays. So let's make an associative array. So someone asked about saving data from an associative array into a file. So let's declare an associative array. And let's store some values into here. So data Nick equals CSE224. Data Scott. CSE121. Data bracket Tina. Is engineering 109. And these odd is engineering 250. I'll throw this this code on the server on Canvas, the shared code area. So let's save this into a file. So I'm going to say for index in $ curly bracket exclamation data bracket @, right? So so this is how we loop over all valid indices. So key equals, so let's say value equals $ curly bracket data bracket $ index. I cannot type. All right, this iterates over all of the indices. So each time we go through this loop, index is going to be another index. It may not be in the same order, but it will be some index, and this will read the element in the associative array associated with that index. So now I have index and value. And if I do something like this, index equals $ index. Let me do this. Teacher equals index. Class equals value. So we'll print out the teacher and the class they teach. So if I run this, right, I see a list of teachers and a list of classes they teach coming to standard out. So if I want to put this into a file, I could say append this to, you know, array file. And in the beginning, I'll copy dev null to this file to zero it out, to make it 0 length. And each of these echo statements will append that current record to the output file. So now if I run main and I look at array file, it's got that record of the associative arrays data. Again, there's nothing magic going on here, right? This is without this, right? This is just our iterator for going through an associative array and showing us the contents of each record. But executing any command with greater than file name causes that command's output to be appended to the file, right? And I copy dev null in the beginning just to start off with an empty file, so that if I run this again, it doesn't, you know, append to what was written by the previous execution. So it starts off with an empty file, and then it just appends each of these records. All right, so that code's on the server, so you can get to it through Canvas. Is this any harder to do in C? Yes and no. So if you want to do these kinds of, are you talking about associative arrays? Or are you talking about the calendar program? Associative arrays are different to do in C. You have to use a package, and the package for that is usually GDVM. And it's pretty simple to use. The calendar program itself, the hardest part about doing that in C would be making the graphical elements. But if I was going to do that, I would probably run the dialog program from inside C and just use that for making the pop-ups. And then I would do the other processing in C. But I actually think it's probably easier to do in Bash. I mean, Bash is so kind of quick and dirty. With these kinds of constructs and with some of the manipulations we can do on strings using awk and sed and so on, it's probably easier in Bash. All right, let's do a short break. And let's come back at 5 minutes. And we'll talk about some other stuff. And no, writing the associative array to a file, this array file business, nothing necessarily to do with PA5. Somebody had asked about writing the contents of an associative array to a file. So this was an example of that, an example of using an iterator and appending to a file. But you may or may not do something similar. All right, so I'll see you back here in about 5 minutes. All right. Just for reference, we've talked about you know how when you do the steam locomotive, you get this image of a train going across the screen, and when you play Rogue, you get, you know, these boxes that you can interact with, and we've talked about how these things happen, and it's done through a package called curses, and curses is a way to do drawing from a C program. And you know, those boxes that we just saw don't look as fancy as the ones we get from Dialogue. And if we wanted to make really fancy graphics from C, we can do it, but we have to get into some more sophisticated libraries. But if you want to do sort of a rudimentary graphical interface from C, curses is not a bad way to do it. And it's the way that, you know, a lot of the older programs in the 80s and such were done. It looks, you know, like old style DOS Windows, but it works, and it's pretty painless. And you know, here's an example program. This is kind of my hello world for curses. Init screen initializes, our screen clears it, and I can use a command like move, and I can give XY coordinates, so a column and a row, and I can move my cursor anywhere I want on the screen. And I can say add character and say, hey, let's draw a character at the current cursor location. And I can also do things like say, hey, let's make a window, which is 5 by 5 sitting at location 5, 5. Let's make a box out of that using asterisks and then add that to our display. And so this simple program will draw a line from 00 to 2020, sleep for 2 seconds, and then draw a box and sleep for 5 seconds. And if you compile this, you need to include the library that has all of these functions in it. And you can include that by saying -L ncurses. And then if you run this, there's my line from 00 to 2020, there's my box. And you can, so it's called ncurses instead of curses. It's derived from curses. You can look at the manual page and see, you know, all the different functions that you can use to display information, to get information from the user, to respond to key presses, and so on and so forth. And so this is what Rogue is written in. This is what, you know, the SL program was written in. And it's not something for the faint of heart, but it's, you know, certainly an option. Like I say, if I was needing to write a C program to do some sort of graphical interface, I would probably just call Dialogue from inside C. And that's easy to do, and we'll look at that probably on Thursday or next week. But anyway, it is an option. So let's see. So the server the ODP we did last time was, I think, 418. So 419. So the last ODP from last week was this put get function. So saving information and then being able to retrieve it elsewhere. And something like this works fine. So I'm declaring a global variable here because I'm declaring it outside of these functions, and I initialize it to 0. When you call put with an argument, it just saves that argument into this global. And when you call get, it just returns the value of this global. And so if I put parentheses 10, and then at some point I say get, it'll return that 10. So that would have worked for ODP 419. All right, ODP 421. So this is another C ODP. And it's dealing with arrays. And remember, the funny thing with arrays in C is there's nothing you can do with an array that tells you how long it is. If I get an argument and I'm told it's a pointer to an int, that means it's an array of integers. But there's nothing I can do by looking at that array to know how long it is, how many integers are in the array. So this function is designed so that it takes a first argument, which tells me how many integers are in the array. So if I have an array containing 10 numbers and I want to add them together, I would call my sum function. My first argument would be a 10. And then the second argument is the array itself. And what your function should do is add up all the elements in the array and return their sum. And how do you know how many elements to add? That's what the first argument does. So make a file sum.c that contains this function, and then write a main program to test it. Right, exercise it, see if it's working correctly. And remember, if you make an array like, you know, integer data bracket 5 equals curly bracket 1 3 7 14 2, this will declare an array and also initialize it. You could also initialize it with 5 equal statements, right? But this is an easy way to declare an array, and then you could say, you know, integer result equals sum 5 comma data, and then print the result. And you should see the sum of these things. I could also call, you know, sum 3 comma data. And my sum function will think, oh, my data contains only 3 numbers, and it should add 1, 3, and 7 and return an 11. And if I happen to call sum 6 comma data, no idea what's going to happen. It could segfault, because it may be that after this 5th element is an area of memory I can't access. Or it may, you know, just add whatever random information happens to be stored after that too. So this is going to give me unpredictable results, but this and this should be well defined. And if I call my sum with a 0 for the beginning, it should just return 0, right? Because we're adding the elements of the array together by successively adding them to a running sum that's initialized to 0. So if you don't have any data to add, just return a 0. So that's the case where the argument is equal to 0. So write your sum function, test it with your own main program, and then link it with the test bed and go ahead and assess it. In that previous 419 example, this was just declaring a global variable named saveval and initializing it to 0. The assignment didn't say what to do if you call get without calling put, but I just decided to initialize it to 0. So it starts off looking as if you said, you know, put 0, but this is just declaring a global integer. All right, and then ODP 423 which will be due Friday morning. So 421 is due Wednesday morning. 423 is due Friday morning. And so this also works with an array of integers and the same pair of arguments, the actual array itself, and then an integer telling you how big the array is. And what Rev should do is reverse the order of the elements in the array. So if my array contains this set of data, then after I call Rev, it should contain this set of data. And remember, when we're dealing with arrays, so let's say I have a main program and I have an array, and I call my rev function like this. And let's say in my rev function, and let me double check the prototype, it's void. So I'll call my first argument len, and I'll call my second argument, I don't know, I'll just call it arg. All right, remember how passing arrays works in C, right? I'm going to say rev 10 comma data. This data refers to this array, right? It's actually equal to the address where this array begins. So in here, I'm declaring my argument as an int star, because I don't know if it's 10 or 10,000, right? So I'm just saying int star. Arg is going to be the address of this array. And if I do something like arg bracket 0 equals 17, when I come back from this function, data bracket 0 will be 17, right? So arg bracket I and data bracket I, these are the same thing. So unlike an integer where, you know, if I just have a plain int and I change its value, it doesn't affect what happens in the caller. When I have an array, if I change an element of that array, it changes in the caller's copy of that array. So for my rev function, all I have to do is manipulate this array. And when I come back from my function, this array will be manipulated accordingly. And so how do we manipulate it? Well, very carefully, right? So I want to swap pairs of elements. So, you know, I'd want to swap these, and I'd want to swap these, and I'd want to leave this the same. But if my array has 4 elements in it, then I'm going to swap the first and the last, and I'm going to swap these middle 2. And so you need to be a little careful about how you go about doing this swapping. So that's the challenge for ODP 423. And so again, you can make your own test program. You can initialize an array however you like. You can call rev and then print out the resulting array and just do that in a loop. Test your program, including the case where there's no arguments, in which case you shouldn't do anything, right? And then link with the test bed and assess the program. All right, any questions on that? Cool. All right, so Tuesday we were talking about regular expressions. I pointed you through these regular expression practice questions. Did anybody have a chance to try any of these? So I'll take that as a no. So let's play with some of these now. All right, cool. So basic patterns, these are kind of getting our feet wet, right? So remove the first cue from a line. And so let's just open a window here. And we can work with these from the command line. We can work with these in sed. We can work inside VI. Let's play with sed, because sed is nice because we can see what we've typed instead of VI. If we type :s/, that typing disappears after we hit enter. So remove the first cue from a line. So sed, substitute cue with nothing. And sed processes files one line at a time, and it begins at the start of the line and it moves through until it finds something that matches our pattern. In this case, our pattern is just the letter Q. So it'll find the first uppercase Q and replace it with what's in between these slashes, which is nothing. So that basically removes the letter Q. So if there's no Q, nothing gets removed, our input is unchanged. If I say quick, that letter Q gets removed. If I have some stuff before, then it keeps all of this, but here's the thing that matched our pattern, and so that got replaced with nothing. And if there's multiple Qs, this is only going to remove the first. If I want to remove all occurrences of Q, we just throw this G at the end of the sed command. And so the G makes this global. So remember this summary of regular expressions. If you put a /G at the end, that replaces all occurrences on this line of old with new. So if we do this, and we say be quick, 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 it gets rid of all of those Qs. All right, removing TH would be the same thing, but instead of looking for a Q, we look for TH. What about removing any occurrence of T followed by any character? So how could we cobble that together? Yeah, so we can use our wild cards. And we can say substitute T dot with //. And so if we say, enter the something, that's the first occurrence of T and it's followed by the letter E. So that T and E get replaced with nothing, they get removed. So I'm using sed here in its kind of default mode, which is to read from standard in and write the output to standard out. And when I'm done giving it input, I can just hit a Control D, which acts like end of file. And yeah, if I put a G at the end, then it gets rid of every place that it finds a T followed by anything else. On the other hand, if I make my line hit, it doesn't make any changes because this T is not followed by any other character. So this does not match that pattern. All right, and then anchors, right? Our anchors are caret and $. So caret is the start of the line. And $sign is the end of the line. And so we can ask sed to match not just a pattern, but to indicate where it is. And so remove the last character from a line. So yeah, somebody put this in chat. Let's look for any character followed by the end of the line. And so that removes the last character. Remove last 3 characters, exactly the same idea. And if my input is something like, ABC, well, it removes those last 3 characters. That's the entire string. So my result is just empty. If my string is like hi, HI, well, nothing in this input line matches this pattern. And so no substitution is made. And so the line is unchanged. And then removing the first 3 characters would be the same thing, just use a caret followed by 3 dots. And removing TH at the beginning would be a caret followed by TH. So if we want to remove the first character, we could do it like that. All right, so things get more interesting when we start working with the registers. So with registers, we can say something like, for example, remove the first 3 and last 3 characters from a line. So we know how to remove the first, we know how to remove the last, but we want to do both of those. So what are some ways we could do that? And you're welcome to use your microphones.
So could you do the caret and then 3 periods, and then you would do open bracket or open bracket or whatever it is. And then oh man, just it would be the wild card, but any character, right?
Yeah, so we could say dot star, which means 0 or more occurrences of anything.
Yeah, and then end that, and then put the 3 periods, and then $,
Perfect.
forward slash, and then forward, and then no $1 now, right? Yeah, or not $, sorry.
Yeah, \1. All right, so why is this going to work? Remember, the main game when we're playing with regular expressions is we have to figure out how to match some or all of our input string, and then we have to specify some replacement or substitution. This is the language of regular expressions. We specify something we want to match, and then something we want to replace or substitute. So if we have an input string like this, and our goal is remove the first 3 and last 3 characters, well, we're going to have to do this in parts, right? First, we need to somehow match the first 3 characters. And we can do that with, caret ... And we can match the last three characters, which is dot, 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 star, or $sign. But this would only match, 3 characters followed by 3 characters followed by the end of the line. We still need to somehow pick up all of this stuff in between. And so that's where we do a dot star. And so now we have a pattern that matches the entire line. Well, we could have just done dot star. That would match the entire line, but that doesn't really help us. We need to do something more fine grain. We need to match 3 characters followed by other stuff, followed by 3 characters, followed by the end of the line. And so this is a nice way to match the entire line, because the stuff that matches this middle part, that's what we want to keep. And so we replace all of this with the contents of what matched this, which is what we call register 1. And so we get that with a \1. And because it's bash, we have to put backslashes in front of these parentheses to escape them. And so we get this glorious mess. Substitute caret dot 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 \paren dot star \paren dot 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 $sign /\1/. So I can do A, B, C, D, E, F, G, H, I, J, and the middle 4 characters are preserved, and the first 3 and last 3 get dropped. And if I put in something like hello, it's not going to change it. Why? Because this pattern does not match the string hello. I can find the beginning of the line followed by 3 characters, but no matter what else I do, I cannot match an additional 3 characters followed by end of the line.
Are we gonna have to worry about greediness and stuff in this course?
Worry about what?
Greediness of regex operations and stuff.
So this is an interesting question, right? So just look at this pattern: 3 dots followed by any number of dots followed by 3 dots followed by end of the line. So if you were trying to write a program to, take this and figure out what it matches, right? The first thing you might think is, okay, so caret is the beginning of the line. That's right here. 3 dots matches those. Now I need any number of any characters. Well, this matches dot star, but so does these 2 things. So does these 3 things. So does the entire rest of this line. But if I try to use, this single character to match dot star, and then I look for 3 characters followed by end of line, it fails. And if I were to take all of this and match that to dot star, and then try to find 3 characters followed by end of line, that will fail. So there's a lot of different ways, as the system is processing this regular expression, that it can try to match this input string to this description. But it turns out in this case, it's got to match exactly these characters right here to this dot star, and then these 3 characters to those 3 dots, and that takes you to the anchor at the end of the line. So processing this regular expression is a complex thing. It actually gets into questions of parsing and language analysis and formal languages and automata theory, and some stuff we'll talk about in CSE224. But it's a tricky thing to do, and sometimes there's ambiguity. So suppose I just said, substitute dot star with haha. And I say this is a test. So if we look at the string, this is a test, and we're looking for a pattern dot star. What will that pattern match? Again, it could just match the letter T, because that is, one occurrence of a dot. It could match the TH. It could match nothing, right? If I have an empty string here in the beginning, that matches the pattern 0 occurrences of a dot. Or it could match the entire string. And there's no other constraints on this. So this is where we have this notion where we say regex are greedy, meaning they will try to match as much as possible. And so in this case, if I type in this is a test, it replaces the entire string with haha. If I say take any number of characters followed by an X and delete that, and I give it a pattern like hexaflexadexagon, right? There are different ways we can match this pattern. We could say HEX, that's 2 characters followed by an X. Or we could say HEXAFLE followed by an X. That's a set of characters followed by an X. Regexes are greedy, so it will match as much as possible, which means it will take all of this and the letter X and say that matches dot star followed by X, and it'll delete all of that and just leave me with agon. So yeah, we do need to know that regexes are greedy. Sometimes that will come up. And it's basically a way of dealing with ambiguities. All right, how do we swap the first 2 characters of a line? All right, that might be a good start. So what's our game plan? Match and replace. So how do we match? How do we match the first 2 characters?
First 2, wouldn't that be, so you do well, you're gonna have 2 periods, right? But you're gonna need to have them, yeah, like that, separated. Yeah, there we go. And you're gonna need an anchor to the front, like, well, yeah, you typed it in chat right there.
So yeah, so let's put an anchor for the beginning. Let's have 2 periods to say we want to match the first 2 characters, but I want to use the things that match those 2 dots. So I'm going to put these inside parentheses. And now this is going to go into register 1. This is going to go into register 2. And so I'm going to replace with \2\1, which will be the second character and the first character. So that changes the first 2 characters. Again, if I only have 1 character, it's not going to make any change, and so I'll just see that verbatim. But if I were to type an X followed by a space, then I get a space followed by an X. Now, in this case, if I don't have this anchor in the beginning, it's still going to do exactly the same thing because regexes begin from the start of the line and try to match. So regexes are greedy and they also start from the beginning of the line. And so whether I have the caret or not, this is going to start with the first character, and that is going to match our dot. And the second character will match this second dot. So that'll satisfy this pattern, and they'll get replaced with the second character followed by the first character. Now, what would happen here if I put a G at the end? What do you think it's going to do?
Is chaos a correct answer?
No, it's actually pretty controlled. But it could be chaos. So the other thing about regular expressions is if I say /G, it says do this as many times as you can on the line, which means it's going to, look for two characters, replace them with those two characters swapped, and then it's going to continue from the next character in the line and see if it can find this pattern again. And if it does, it will do the substitution, and then it will start with the next character after what it matched here and try to do this pattern again. So if I type something like this, it swaps every pair of characters. All right, what about swapping the first and the last character? Cool, so I see it in chat. So swapping first and last. So let's say that's our input string. So I've somehow got to get a hold of this character and that character. And right, the way you get a hold of these things is by specifying a search pattern. So how do I match the first character? We did this a few minutes ago. How do you match the first character in a string using a regular expression? Yeah, so caret will anchor at the beginning, and then period will match one character. And how do you match the last character of a string? So a period matches any character followed by an anchor $. That's the last one. And so this will pick up that, and this will pick up that. But we also need to pick up all of this stuff in the middle. And how do we match that stuff in the middle, which is, 0 or more characters? So yeah, we can use this asterisk preceded by a dot, which says 0 or more occurrences of any character. So now we've got an expression that matches our original string. And next, we just have to take certain pieces of this and move them into registers so that we can use them in a replacement pattern. So let's put parentheses around each of these. and the usual backslashes in the front, which I'm not going to draw here. And what do we want to replace this with? So what's the first thing we want to output? Yeah, first thing we want to output is the last character, which went into register 3 because it was the third search pattern inside parentheses. And then we want that followed by the middle of our input, which is register 2. And we want that followed by the first character, which is register 1. So there's your rev program from the ODP done in a single line of sed. All right, so remember, don't memorize these, right? Nobody memorizes these. That's the path of pain. Figure out how to use these small number of things that are in that regex summary. It's a half a page description on Canvas. Figure out how to use those to do something like this, right? That's what you want to practice. You don't want to go through all of these examples and look at the video and try to memorize these. You don't even want to try to understand these necessarily, because reading a regular expression is really hard, right? If someone gives me this and says, what does it do? I'm probably just going to walk away because I don't know how to read this. I mean, it's all looks the same, right? But writing a regular expression is pretty straightforward once you understand the basic pieces. So the challenge in dealing with regular expressions is getting some practice with using these constructs, anchors, wildcards, asterisks, registers, and so on. And it's just like, you know, if somebody shows you a program for detecting palindromes in C, your takeaway should not be to commit that program to memory, right? It should be to scratch your head over the parts of the program you don't understand. What is string length doing, right? What is bracket I-1 mean, right? And use that to understand why the program works, so that now if somebody gives you a different program, you can write that. So it's the same thing with regular expressions. It's a language. It's a different way of describing an intent to a computer. And it's a very peculiar way because, you know, this is a hard thing to ask a computer to do. And so it's closer to like a low level language than a high level language. And it takes practice to get good with giving these instructions to the computer. So some of these problems are good practice for that. I think there's like a limit of 9 registers, but I'm not sure. I've never done anything that had more than 9 registers to it, but it may be smart enough to understand \10 is register 10. Yeah, so \10 looks like register 1 followed by the character 0. So there may be a limit of 9. So you can practice these things further online. There's a ton of websites that will help you play around with these things. So regex101.com is an example. And let's do substitution. And so I can say, you know, let's type a test string. So this is a test. And let's search for caret. And so the syntax is different on here, right? We don't need to backslash our parentheses for this. So I'm just going to say period dot star period dot $. And so there's a regular expression and it's color coding, right? So this dot is colored differently, but I've got three expressions in parentheses here, and I can see, for example, if I hover over this first character T, it tells me that's group 1. So it calls it a group instead of a register. It contains a T. Group 2 is the middle of the string. Group 3 is the end of the string. And I can see over here, group 1, group 2, group 3, the pieces that are matching this. Now, if I throw an extra dot in this first set of parentheses, right? Group 1 is TH, group 3 is that last T, group 2 is the stuff in the middle. And if I want to do replacement values, well, for us, we do backslashes, but I could do $3, $2, $1 to replace with those. So, you know, the syntax is a little different, and the syntax that works for SED may not work for VI, for example. This is just an example of a site that you can use to play around with some of this stuff. So if I match a dot star, it eats up, you know, the entire string. And if I say substitute with haha, there's what my output is. If I say dot star followed by test, and I replace this with $1 followed by haha, right? It takes that part that matches this piece of my expression and it keeps that in $1. If I don't put test at the end, the dot star will eat the entire string and it'll replace that with the entire string followed by haha. So if you Google regex calculator, you'll see a bunch of sites like this. Regex101.com seems to be a pretty decent one. Like I say, the syntax is different. We don't escape the parentheses. We use $ instead of backslash for the substitution, but it lets you pretty quickly see not only what a regular expression does, but why it's doing it, right? So if I search for caret dot, you can see that my first group is matching T, my second group is matching H. And if I replace this with $2, $1, you can see what's happening. The TH is getting replaced with HT. If I wanted to replace an entire line with just the first 2 characters with everything else on the line removed, I could add an extra match dot star, and that will chew up the rest of the line, and then it'll say, okay, go ahead and replace that entire line with just this pattern. So if I've got a class registry that looks like this, and I want to move the first names into the beginning, I can say something like this. Right, take any number of characters followed by a space followed by any number of characters and replace that with the second name followed by a comma space followed by the first name. And so now I've got these files in that format. And now I can say, substitute the end of the line with a bunch of underscores. And now I've got, you know, a line after each name. And I'm going to use this to pass around to students in the beginning of class so they can sign in. But my lines have different lengths and I'd like them to all end at the same point. So now I can do something like this. Let's start at the beginning of the line. Let's just match a bunch of characters followed by anything else to the end of the line and just replace it with a pattern that matched the beginning. So it's going to take this many characters and preserve those and get rid of everything else. And so now all my lines end at the same point. And now I can go ahead and I can make my lines longer by adding that to the end of each line. And now I want to put a space in between each line. So I can say substitute the end of my line with, and we're going to use that escape we talked about in the very beginning. We're going to hit Control V followed by an Enter key, and it adds a blank line. And so I can save that as my names file. And now I can say sort names, put that into names 2. And now I've got an alphabetized attendance sheet. Oh, that didn't work. Sort this into names 2. So now it's alphabetized. And then I can add an extra space to the end of each. And now I've got my attendance sheet. And I can put some information in the top for name and date. And now I print this out and make copies, and that's what I bring into my 101 class, right? And it may feel like a lot of steps, but if you understand regular expressions, you can do this without really thinking about it. So play around with these, ask questions about them next class. Try a website like, regex 101, or some of these other ones. So regex tester or regexer and so on, and see how far you can get with these. I'm not going to give you something really long and horrifying on a test, right? But I may give you a pretty simple regular expression and ask you to show me what it does to a set of input lines. And so some of the simpler things, the anchors, the wildcards, using registers, that kind of stuff is all fair game. All right, so Thursday we can talk about PA5 questions, ODP questions, regex questions, and then I think I'm going to either go into processes or do a kind of overview of bash commands and bash concepts, kind of do a bit of review for the exam, and just sort of summarize all of the stuff that we've been doing and work through some examples of that and pick up a few new things that we haven't done yet, like curl, for example, for scraping web pages. And so we'll do that Tuesday or Thursday, and then we'll do processes on the other day. All right, that's all I got today. Have a great afternoon. I will see everybody next time.
See ya.
All right, bye.
Bye.